Hello everyone. This is going to be covering the second section of our chapter 48, Human Impacts on the Biosphere, starting with us talking about pollution. So, what are pollutants in the first place? Pollutants are basically anything man-made or natural that actually gets released into the soil, air, or water in greater than natural amounts. So anything greater than a natural amount is basically considered a pollutant into the actual atmosphere itself. So it can come from point sources, and these are going to be the easiest to control. So basically, we can actually identify the actual source of where that pollution is coming from, and we can immediately take action on it. So for example, if a factory is leaking some sort of chemical into a runoff or a river, we can automatically identify that and stop it from occurring. The hard one that's hard to control is going to be non-point sources. Reason being, it actually comes from a very widespread area releasing that type of pollutant. For a good example would be oil runoff from roads or driveways. The reason this is so hard is because just imagine something as simple as your car leaking, let's say 10 drops of oil. Well, if your car is leaking 10 drops of oil down your driveway, multiply that by 3 million cars that might be leaking 10 drops of oil as well in the actual, let's say, surrounding area or in the state or anything like that. If you have 3 million cars leaking 10 drops of oil, that can actually accumulate very quickly to 200 gallons of oil in those 10 drops when you calculate 3 million cars having that kind of oil runoff. That would basically eventually bleed into our underground our groundwater system and then go off into streams and rivers and ultimately maybe even to the ocean. Okay, so pollutions are actually when those pollutants that we just talked about are introduced into the environment, and they can cause a multiple of different damages throughout our atmosphere. They can actually do anything from forming acid rain, which we're going to talk about in the next slide, and they can actually allow for bioaccumulation in organisms. So this is one of the outcomes that comes from pollution itself. Acid rain can actually be formed when you actually have water and airborne pollutants fall, and it actually falls back onto the earth as acidic precipitation. Normal rain has about a pH greater than or equal to 5, which is still acidic because it's below the 7 neutral point. So it's still acidic, but it's slightly acidic. But acid rain actually typically has a pH of 4. So that is actually a lot more, 100 times more acidic than the pH of 5. So what happens is we have sulfur and nitrogen oxides that are common air pollutants that can come from, let's say, combustion of gas and oil. And those, like I said, those are actually mixed with actual water and get pulled up through transpiration and then eventually fall back down as acidic rain. So what can that acidic rain do? So one thing that can do is actually prevent fish and their offspring or their eggs from developing correctly. It can also kill adult fish because of the acidity that actually puts into the water when it falls back down. It can also burn tree leaves, and it's going to have a way more detrimental effect on the trees that are higher, and let's say in a canopy area, versus the ones that are lower, just due to the fact that they're going to be the ones that are more exposed to that to the actual precipitation coming back down. And these are both two diagrams that are found in your textbook. The one down here is actually a picture of the Great Smoky Mountains National Park, and due to the acid rain, you can actually see that it's actually falling back down and killing the leaves. And also, when it not only falls down and kills the leaves, it is also going to be damaging all the soil and the nutrients in the soil that when it does hit the ground level as well. Another picture you have in your textbook is this picture above right here. This one is actually showing the acidity of the rainfall according to where we're looking at the United States. So where would actually you see more acidic rain happening? So we're going to obviously see the red one is going to be less than or equal to 4 on the pH scale, which is highly acidic, versus over here greater than 5, which would be more going towards the slightly acidic or even maybe neutral levels. So the West Coast actually has the more normal levels of pH, up in the higher 5s and 6s. But over here on the East Coast, you can actually see a lot of acid rain occurring over here. And so like we said, two effects of pollution, and two damaging effects in that case, are going to be acid rain, and also we talked about the bioaccumulation in organisms. So you're going to want to know the difference between bioaccumulation and biological magnification, which is also coming up in the next slide. So bioaccumulation is basically when an organism takes up an actual pollutant from the environment. It actually causes the amount of that pollutant to increase in their body tissue over time. Okay, this is actually very, very harmful also, because obviously the older an organism is, the higher amount of bioaccumulation they actually have within their tissues. And specifically, most organisms store a lot of these pollutants in fatty acids, or in their fatty tissues themselves, which we'll talk about in just a second. But let's talk about how bioaccumulation can be actually useful. So in this case of an actual, let's say, organism like a frog or amphibian or even humans, it could be very detrimental to the health of that organism. But it can also be detrimental to plants, but that is actually useful and helpful to us, because since the plants have the ability to bioaccumulate and basically intake those toxic, let's say metals, for example, they're actually going to be helping with phytoremediation of polluted soils, because basically they're absorbing a lot of that pollutant soil, let's say, or let's say the metal in the actual soil, and absorbing it, and then they're going to actually be intensifying the actual pollutant itself, and then we can actually control it and maybe even remove those plants from the actual, let's say we're talking about a farmland. We can actually use those plants to remove the metals from the soil, and then remove the plants themselves and get rid of all those toxic pollutants that were once found there that we want to go ahead and remove. So phytoremediation is a very nice, low cost and solar energy driven cleanup technique. So it is very, very, very useful. Now, we were just talking about animal accumulation of pollutants as well, and I did point out to you that in animals, pollutants accumulate in the actual fatty tissue of those guys. Okay, so like I said, over time, the organisms that actually live longest are going to have the higher percentage of pollutants in their actual fatty tissues. Remember, we store fat as energy storage in our bodies, so it really doesn't go anywhere unless we're kind of fasting or anything like that. But ultimately, you're going to be storing fat throughout your life. So that's why longer living organisms are going to actually accumulate that pollutant in their fatty tissues a lot longer than shorter lived organisms themselves. So that's bioaccumulation, what we were just talking about. Remember, it's basically when an organism's tissue takes up and stores a pollutant in their tissues themselves. So now, what is biological magnification? So this is kind of like how we were talking about the food chain before. So you know how on the food chain, we have, let's say at the very bottom of our food chain, we have the primary producers. Then they get eaten by the primary consumers. And then next, the primary consumers will get eaten by a secondary consumer. So if you recall, every single time, let's say a primary producer gets eaten by a primary consumer, only about 10% of the actual energy is transferred to the next level up. 90% or so of the actual energy is actually lost as heat. So with that being said, that's why primary consumers and secondary consumers have to actually eat more, so they can obviously get enough energy to go ahead and accommodate what they need. So for example, pesticides on grass are used to kill insects. Okay, so primary producers, we're talking about the grass, for example. Well, what eats grass? Well, rabbits eat grass. So if rabbits are now eating grass that has pesticides on them, which is basically above the normal level that's naturally found in nature, then that's going to be a pollutant that rabbit is actually ingesting. So now it already pretty much amplified due to it already being on the primary producers and getting, let's say, eaten by a couple of insects, but also by the rabbit. So now it's actually been magnified right there. And then the secondary consumer comes in, let's say the bald eagle, for example. Now the bald eagle is going to eat the rabbit, and now that biological pollutant is going to be magnified even more. Okay, so as one organism eats another one, that magnification of that pollutant concentration in their bodies actually magnifies as well. And like I said, they do have to eat a lot of it because only about 10% of the actual consumption results in about 10% of their energy, okay, by consuming that organism. So they have to eat a lot of it. So it's not like one bald eagle is just going to eat one rabbit. No, they're going to eat quite a few of those rabbits to gain the energy they need to sustain their lifestyle. So let's go ahead now and refer back to human trash as a pollutant itself. So back in the day, as you guys know, humans used to actually just bury their trash underground or even send it out to sea. Obviously, it's kind of like the out of sight, out of mind mentality. Well, obviously, we realized pretty quickly that that was not a safe means of disposal. Reason being, whenever we actually bury our garbage underground, there's a lot of things that can actually bleed out into our groundwater. Let's say, for example, the lead that bleeds out of your batteries. When we actually just throw them in the landfill, cover them up, well, that lead's going to eventually bleed out into the actual groundwater and then maybe even be consumed by different organisms and then eventually back into our own water system. So very dangerous. Also, we used to actually use solid waste and dump it into oceans, thinking, okay, out of sight, out of mind once again. Well, that wasn't good either because that actually harmed a lot of wildlife. So this is a picture you can actually find in your textbook as well. This is really sad because this is actually an albatross chick, which is a seabird type of animal, but it's actually a chick. So what happened was, if you actually look at this in your textbook, you'll actually see a really good picture of it, but in this chick, they actually found that one of the pieces of the plastic in its intestinal tract cut through its intestinal system and actually cut the bird or the chick wide open. What the scientists actually found was 300 pieces of plastic in this actual seabird's body. So what they can assume, because it was a chick, was that the parents who were out at sea were collecting the plastic and feeding it to this chick, thinking it was actually food. So that's just showing you, how detrimental us dumping our solid waste into the oceans can actually be. Another thing that we have a big issue with is, let's say, for example, plastic bags, water bottles, things of that nature. Those things that you kind of see around, let's say on the highway, will eventually end up in some sort of storm drain. Well, storm drains will eventually lead into streams and maybe even rivers, and then they'll actually go ahead and fall into the actual open ocean. And oceans can actually carry very large amounts of plastic thousands of miles away. So even if you don't think one little plastic bottle is doing such a great harm and you pass by it, you never know where it can actually end up. Like this poor chick had to die from consuming plastic because, that's what the parents saw or found out in the actual ocean. So, the Great Pacific Garbage Patch. What is this that I'm talking about? This is actually a region of the North Central Pacific you're looking at. And we actually refer to this place as Island of Trash. That's literally its nickname, Island of Trash. Reason being, it is completely covered in miles and miles and miles of plastic in this area. It literally looks like confetti. That's how, when you're actually, they actually flown drones over this area, it literally looks like confetti like plastic. And it literally just swirls around in this area. And to give you an idea of how large this area is, the Island of Trash, it's actually it's big enough to cover the area the size of Texas. Okay, so remember how I said the last slide how basically how, let's say, a water bottle can come from a storm drain into a stream, into a river, and finally to the ocean, and the ocean carry large amounts of plastic thousands of miles away. So this is kind of like the result of that. So the problem with this, though, is not just the fact that we have this huge, massive catastrophe of plastics in the ocean, what we call island of trash once again. It's the problem is that plastic actually absorbs and concentrates toxic compounds such as pesticides and chemicals around them. So not only is there plastic there, it's actually absorbing those pesticides and chemicals, so it's actually intensifying what they actually carry. So obviously, that poor bird, that chick, that actually albatross chick, not only consumed plastic, but if the parents actually came out here to the island of trash to get that plastic because they thought it looked like food to feed to the chick, they were not only feeding their own chick plastic, but also contaminated plastic that actually had a whole bunch of chemicals and pesticides in it. So it's really, really sad. So when we're talking about pollutants, we also need to go ahead and talk about the ozone layer. Okay, the ozone layer is actually an area that has high levels of O3 concentrations in the upper atmosphere. O3 is actually known as ozone, or you can also call it the triatomic oxygen. So this is actually an ozone layer, and it is actually good to have that ozone molecule there because it actually absorbs most of the UV radiation that comes from the actual incoming sunlight. As you all know, just like how if you go out to the beach for a whole day, you want to put on sunscreen because actually that can actually cause skin cancer. Reason being, you're actually killing the epidermal layer of your skin cells. So your body needs to regenerate more and undergo mitosis and regenerate more skin cells to replace the ones that had gotten burnt that day. Let's say you spent 10 hours out in the sun. So that just leads to more chances that mutations can occur and ultimately lead to cancer, even if that's the case. So as the ozone layer is getting depleted, guess what that's doing for us? Okay, it's actually allowing more of the UV radiation to come through that was once absorbed, okay, and protecting us. Now it's actually allowing that to come through, so that's being pretty much giving ourselves more exposure to the actual UV rays and ultimately going to be leading to increasing cancer rates and also decreasing photosynthesis rates as well. So what the human's impact is on ozone thinning. So chlorofluorocarbons, or we refer to as CFCs, these are the main ozone destroyers. These were once widely used as propellants, coolants, and also used in plastic foams. In response to the threat of the ozone thinning, countries have agreed in the 1987 Montreal Protocol to phase out these chlorofluorocarbons because of how detrimental and how damaging they were to the actual ozone layer. So we can't talk about human impacts on the biosphere without talking about global climate change. So, as you all have noticed in the news, we've been seeing how average temperatures each year are increasing, and it's actually reaching some record highs lately, and this is leading to some serious changes in our actual environments. So for one, it's actually causing glacial melting to contribute to rising sea levels. What that's doing is the glaciers are actually melting, the sea levels are rising. Average sea level has been increasing by 8 inches over the past century. Well, naturally, you have higher sea levels. That also means that where there was once coastal wetlands, they're actually covered by the ocean now, so they're disappearing themselves. So it's actually losing land in the result of these increase of sea level as well. Not only do we have the glaciers melting, rising sea levels causing issues, but there's also composition of seawater that's changing as well. So waters of the upper Atlantic have become less salty at the poles, while tropical waters are becoming saltier as well. Seawater itself is becoming more acidic, which is obviously affecting all marine life, For example, it can actually be very, very detrimental to coral reefs or any kind of living organisms down below. So what can actually result from global warming? Well, for one, deciduous trees are going to be basically leafing out earlier, and spring blooming flowers are going to actually flower earlier as well. That's going to be affecting how these guys are actually going to be reproducing, or even dropping their seeds or anything of that nature. So that will actually be affecting all of that in regards to plants and trees. It might also be affecting animal migration and breeding patterns. It's going to be causing death of ecosystems, as certain animals can definitely not always adjust quickly to temperature change, maybe even wiping out a whole species altogether. An example is the actual coral reef bleaching that's occurring right now. Since coral reefs cannot actually move, they're immobile, they cannot move to an area that is actually allowing for sunlight to penetrate those deeper waters because of the rising sea levels, so they pretty much die off completely, which is what we're seeing a lot of right now, especially in the Great Reef over in Australia. There can also be a rise in human disease as well due to global warming, because it's going to allow for more viruses to live, bacteria to live, and actually replicate a lot easier as well. So we actually measure a region's biodiversity, or its aka biological wealth, at 3 different levels. The first one is by measuring the genetic diversity within a species. So basically, for example, we have very, very little genetic diversity within cheetahs themselves because there's not a lot of them. Another thing is we can actually measure it by species diversity. In other words, how many different species we actually have in that specific region. And another way we can actually measure biodiversity is by the ecosystem's diversity itself. So right now, biodiversity is actually declining in all 3 levels in all the regions that conservation biologists have studied. What is conservation biology definition anyway? It is actually the field that addresses these declines, the genetic diversity within species, species diversity, and ecosystem diversity. And the way they do that is they actually survey the ranges of biodiversity, and ultimately their goal is to find ways to maintain these areas, but it has to be a give and take. So they have to find ways to maintain the areas and protect the organisms within the area, but it also has to be able to benefit human population. So biodiversity hotspots. Okay, ultimately, healthy ecosystems are essential to human survival because other organisms are basically what's producing our oxygen, our food. It's basically by decomposing our wastes, all that kind of. So basically, we rely on these other organisms in our ecosystems to survive. Let's say there was no more plants on Earth. Well, guess what plants make? Plants give us our oxygen to live. So if we're killing off all the soil, we're removing all the nutrients available to the plants themselves, they're going to die off and we die off with them. So conservation biologists help make decisions about which regions should be protected first by identifying those biodiverse hotspots. So a biodiverse hotspot is ultimately places where only certain species can be found, that they are found nowhere else in the world naturally, but these areas are also under a great threat for actually complete destruction. Good example, Madagascar. So talking about all this damage that actually humans have had on the entire atmosphere, let's go ahead and talk about some ways that we can actually help either preserve those areas or even restore them back. Number 1, ecological restoration. That's pretty much necessary when an ecosystem is so damaged that you can no longer conserve it, preserve it, because ultimately it's not going to restore itself. So what we actually do there is we're going to work to bring about the renewal of natural ecosystem that has ultimately been degraded, destroyed, deforested, desertified using modern technologies. What you're looking at in this picture and this is actually found in your textbook as well, is the current restoration efforts that are now taking place to help reverse some of the damage done to these marshlands. So why are these Louisiana coastal wetlands so important? Well, first of all, 40% of the coastal wetlands in the entire U.S. are the ones found in Louisiana. Marshes themselves are ecologically and economically basically a treasure for biodiversity, and they're currently in trouble. Sediment that usually or normally replenishes the sediment of the marshland loss into the sea is not being replenished due to dams that we've built and levees that were built upstream of these marshes. So once again, sediment gets lost out to sea and it can no longer be replenished because of our dams or levees that we actually built up around the marshes. Another issue that has actually led to the degrading of these areas is that we've actually built channels in these marshes to go through them in search of oil, or even because we found oil and we're actually building a channel for the purposes of oil production in these areas as well. Well, by building channels in these marshlands, that's going to allow for soil erosion to occur. On top of soil erosion, we actually have those rising sea levels still that are happening. Well, rising sea levels can actually kill existing plants in these marshlands because of flooding. So back to the very beginning of what I was saying, this is actually a picture of the efforts currently in place trying to now go ahead and reverse some of this damage that we've actually done to these marshlands in the Louisiana's coastal wetland area. Right here where you actually are seeing these the square sediments, each of these squares is actually sediment that was actually brought back in and planted within the marsh area. Okay, basically trying to replenish the marsh grassland areas because this was actually becoming open water. So by going ahead and bringing back the grasses in the area and creating surface area, we're actually going to allow for more animal abundance and more species richness to increase in this area as well. In all actuality, we know very few things about the future of our planet. Okay. This is what kind of scares people right here, because scientists predict that the sun will kill us in about 1 billion years. Okay, obviously we won't live that long to see it. Neither will our kids, neither will our kids' But due to the actual practices that we're actually involved in current times, and due to the amount of deforestation, degradation, and everything that we're doing to our ecosystems, it can actually come a lot quicker than that. Well, how quick is something for me to be scared of versus 1 billion years? Well, if we don't do anything now, they say that 1 billion years, which is the prediction of scientists for the sun to kill us alone, could potentially be only 100 years away. Once again, due to the rate that we're actually degrading, deforesting, desertifying our current environment now. So what are some things you can do? Well, for one thing, those handy dandy electronic devices that we all use in modern day, they are actually made of non-renewable mineral resources. So one thing you can do is, instead of going out and actually buying the newest and coolest new device, you can actually fix your current device and try to use it for a lot longer time period. Another thing, don't litter. Because like an example I gave you about that one little water bottle, just think about that albatross chick that got fed all that 300 pieces of plastic and how it can end up an island of trash out in the ocean. So don't litter. Try to recycle. Try to use recycled products, and then reduce energy usage itself. So those are small things you can do that will make a huge impact in everyday life, especially in marine animals currently. Another big step you can take is actually volunteer in cleanup groups in your local area that help to clean up rivers, roadways, because even if it's, like I said, trash just on the roadway, that will eventually lead and kind of bleed into our actual ocean system one way or the other. Also, you can vote for policies that help protect our ecosystems versus the ones that actually just increase the economy or have a greater economical impact for a monetary gain.